Welcome back to This Explainer. Today, we're pulling back the curtain to reveal how the absolute messiest parts of curriculum design actually engineered a highly refined learning experience. If you've been following along, you know that teaching code to legal minds isn't just a simple translation exercise, right? It requires completely deconstructing how an expert already thinks. Lawyers are brilliant, highly educated professionals, which means we can't just pour in new facts. We actually have to untangle their existing expertise. So today, we're focusing on the dithering DNA of the curriculum. We're going to see how months of collaborative and frankly frustrating back and forth directly shape the master syllabus.
So, picture this, a pivotal moment from the early Lex Clinic coordination calls. The team is totally convinced they have this perfectly structured lesson plan ready to go. But then, during an office hour session, Kyle MacLean-Smith basically stops everyone in their tracks. He realized the team was operating on these massive, hidden assumptions about what their students already knew regarding how a computer holds data. They were designing these advanced lessons only to discover they needed to back up 5 full steps just to find the actual starting line.
All right, let's step into part 1. Welcome to the factory, collaborative dithering. Stepping onto the noisy factory floor of those early brainstorming sessions, it's clear this wasn't some clean, linear process. It was a messy, iterative journey of literally ripping up syllabuses and rebuilding them from scratch over and over. By continuously challenging each other on these calls, the creators realized they couldn't just throw programming syntax at legal professionals. No way. They had to first understand the specific cognitive baggage that lawyers bring to the table. Because let's face it, when your brain is already deeply wired for one highly formalized system, entirely new frameworks tend to just bounce right off.
Which brings us to part 2, the raw material, the legal conceptual gap.
You know, you simply cannot forge a new tool without knowing the exact properties of the metal you're striking. Lawyers already excel at logic. They naturally think in complex, nested conditionals. They live and breathe if this, then that scenarios every single day. But trying to collapse that natural language logic into strict, deterministic code reveals a massive gap in how they perceive information. Their logical reasoning? Flawless. But their familiarity with programmatic syntax and active execution environments? Essentially zero.
Think about it like this. The core friction point is transitioning a mind from viewing information as permanently frozen on a page to seeing it as an active, real-time performance. Legal professionals are heavily trained in what we call static fixation. They spend their entire careers looking at printed paper, frozen PDFs, or static grid cells. To them, a document is dead. Programming, however, happens on an active canvas. It's a runtime environment where data is constantly moving, changing, and being validated by the machine. Code is alive, and grasping that is a massive conceptual leap.
Moving right along to Part 3, Engineering the Scaffolding, Module 4.
This exact realization led to a massive restructuring of the master curriculum. We carved out an extensive 2-week block, Module 4, dedicated entirely to heavily reinforcing a single foundational topic, variable assignment. Now, you might be looking at this and wondering, why on earth would you spend 4 entire lessons on one single concept? To an experienced programmer, spending almost an hour of instruction purely on binding a piece of data to a name seems like absolute overkill.
Well, it turns out this isn't redundant at all. The collaborative dithering, all those hours of arguing and testing on coordination calls, revealed a massive blind spot. Variable assignment wasn't just one single hurdle for a lawyer. It was actually 4 completely separate overlapping hurdles masquerading as one. We kept tripping up in early testing until we finally realized we had to meticulously craft a highly refined feature to dismantle these blocks one by one.
Let's check out Part 4, the final widgets, 4 unique cognitive hurdles. Stepping off the factory floor and into the showroom, we can deconstruct the final, polished widgets produced by this intensive manufacturing process. Module 4 acts as a 4-part scaffold. It's an incredibly deliberate ladder. You absolutely cannot teach a legal professional syntax until they understand the environment. You can't teach them iMechanics until they master the syntax. If you skip even one of these sequential steps, the entire scaffolding just collapses under the weight of their existing biases.
The very first widget tackles the environment. Interestingly, this specific lesson doesn't even teach code syntax. It exists purely to physically demonstrate the active canvas. We literally force the student to watch data actively processed and manipulated in real time, dragging their mindset kicking and screaming away from that frozen PDF mentality. They have to see the machine actually execute a command and move data around before they can trust the environment they're working in.
Next up, we have to establish boundaries. In law, a word's fluid, debatable meaning is often a feature, not a bug, right? It leaves room for argument. But in programming, there is absolutely zero room for interpretation. If you try to stuff a plain text string into a Boolean true or false bucket, the entire system instantly crashes. So this step painstakingly demystifies those strict structural constraints, contrasting the comfort of legal vagueness with the rigid reality of strict typing domains.
And that brings us to the third hurdle, which is honestly the ultimate linguistic trap for legal professionals. When a lawyer argues a case or drafts a contract, they use the word equals super loosely to mean two concepts are identical or just that one idea is associated with another. It's fluid in everyday English. But in code, mixing those two distinct concepts up is entirely fatal. We have to pause and seriously ask, does equals actually mean equals?
We have to radically separate the grammatical reality of code from everyday English. A single equals sign assigns a value to a variable. It simply drops an item into a bucket. A double equals sign checks a condition to see if two things are mathematically identical. For a lawyer, decoupling the single equals from the double equals is an absolute baseline requirement for achieving code literacy. Until this distinction is hardwired, writing functional logic is just impossible. Finally, there's a physical cognitive shift. We actually have to actively retrain the lawyer's eye to scan from right to left, overcoming decades of English prose bias. Think about it. When you see x equals 10, your physical instinct is to read left to right. But the computer doesn't do that at all. The computer evaluates the entire right side of the equation first, doing all the background math to figure out what 10 is, and only then does it store that result in the left bucket, x. Retraining this physical eye movement was a real game changer.
And that brings us to our final section, Part 5, the pedagogical magic, catching students at level 0.
So what's the big takeaway here? Why does all of this granular, behind-the-scenes dithering actually matter for your own learning journey? It matters because every single identified blind spot was met with a precise, engineered curriculum solution. The severe problem of static fixation? Neutralized by introducing the active canvas. Legal vagueness? Effectively countered with strict typing domains. And that deeply ingrained English prose bias was physically overwritten with right-to-left eye mechanics.
This right here is the ultimate payoff of our dithering DNA. By acknowledging those messy, frustrating moments on the factory floor, the moments of saying, wait, we actually need to go back a few steps, the final product becomes an incredibly efficient machine for transferring knowledge. Catching students at absolute level 0 isn't useless duplication at all. It ensures the foundation is flawless, and honestly, that is true pedagogical magic.
The strategies we uncovered in those intensive coordination calls go way beyond just teaching lawyers to code. They're a universal blueprint for teaching anything complex to any highly trained expert. I'll leave you with this thought. If we can fundamentally re-engineer code execution for the legal mind by anticipating their exact friction points, what other complex subjects can we unlock by deconstructing our own hidden biases? Thanks for joining me on the factory floor today, and keep questioning how you learn.